Hey everyone, today we are going to start exercise number 3.2. So let's start with the first question. The first question says, let A and B be two finite sets such that n of A is equal to 24, n of B is equal to 18, and n of A union B is equal to 31. Now this is the given data. What do we need to find? We need to find the common values between A and B. Simply we need to find n of A intersection B. So in order to find this, we will use the first formula for two overlapping sets A and B, and that formula is the number of A union B is equal to the number of A plus the number of B subtracted from the number of A intersection B. Now we need to place our values that we got from the question. So A union B is equal to 31, A is equal to 24, and B is equal to 18. So 31 is equal to 24 plus 18 subtracted from what? N of A intersection B. So when we add 24 with 18, we get n of A minus B is in the negative. We will move this to the left side. Because of this, 31 will come to the right side. So this means that the n of A intersection B is equal to 24 plus 18 subtracted from 31. So if 24 is added with 18 then subtracted from 31, then the answer will be 11. So number of A intersection B is 11. Now if we want to represent this data by a Venn diagram, how can we do that? So first we will draw the first set, which is A. Then I'll draw the second set, which is B, but these both sets should overlap with each other. Then I'll call this A, I'll call this set B, and then I'll draw a rectangle outside of these two sets to indicate the universal set. Now what will I do next? In the middle, I'll just write 11. Why? Because it was the intersection of both A and B, and as we know, 24 was a element of A while 18 was an element of B. So if we subtract these both values by 11, we will get the actual value that we need to place in our Venn diagram. So 18 minus 11, if we subtract 18 with 11, we will get 7. So I'll place 7 here. And if we subtract 24 with 11, we will get 13. So I'll place 13 here. Let's attempt question number 2. Question number 2 states, if n of A minus B, so if n of A minus B is equal to 23 and n of A union B is equal to 44, then n of A intersection B is equal to 2. Now we need to find n of B minus A, and we need to find the value of B. So how can we find both of these values? So firstly, we will use the formula to find n bracket B minus A, and then after achieving that value, we will find n of B. So I'll use the first formula for any two overlapping sets, which is n of A union B is equal to n of A minus B added with n of A intersection B, and then again added with B minus A. Added with B minus A. Okay, so I'll place the values. A union B is equal to 44. Then A minus B is 25. A intersection B is 2, and N of B minus A will just remain as the same. Okay, so if we add 25 with 2, we get 27. 44 is equal to 27 being added with the number of B minus A. So if we take 27 to the left side, what will happen that it will be converted to a negative value. So 44 minus 27 will be equal to the number of B minus A. So 44 minus 27 is equal to 17. So 17 is the value of N of B minus A. Now we found N of B minus A, but we still need to find N of B. So in the question, the formula is given for finding N of B, which is equal to the N of A intersection B, and then it is added with the N of B minus A. So we'll just place the values to find N of B. So N of A intersection B is 2, and then the value which we found right now, B minus A, is 17. So if we add 17 with 2, the resultant will be 19. So the answer for N of B is equal to 19. Now if I want to represent this data, so how will I do that? I'll create the first set, which is A, then I'll create the second set, which is B. I'll also label them A and B. Now in the middle, what value do we have? We have 2. So we have B, so 19. If it is subtracted from 2, the resultant is 17. So I'll place 17 in B. And then what is the value of A? The value of A wasn't given. The value of A wasn't given. So if the value of A was given, then we would subtract it from 2 and add the value of A here. And then we would create a rectangle. And we would call this the universal set. And we would make the sign of the universal set right here. Now let's attempt question number 4. Question number 4 states that in a street with 50 houses, 25 houses have lawns, 32 houses have car porches, and 15 have both lawn and car porch. So first, the universal set is given, which is 50. Then the houses with lawns are given, and that is equal to 25. Then the number of houses with car porches are given, which is equal to 32. Then what does it say? And 15 houses have both lawn and car porch. This means that the intersection between lawn and car porch is equal to 15. So this is the given data. So what do we need to do next? So what do we need to do next? We need to find how many houses have neither lawn nor porch. So first we will find the number of L union C, which is lawn union car porch. So I'll write number of lawn union car porch. It is equal to number of L plus number of C subtracted from their intersection. So I'll just write their values, which is 25 added with 32 subtracted from 15. So when we add and subtract them, we will have the value of L union C. So first we do not need to miss this step. N of L union C is equal to N of L being added with N of C, then subtracted from N of L intersection C. After this formula, you can just place your values. So the number of lawn union car porch is equal to 42. Now, if we subtract the universal set from lawn union carch, we will find those houses which have neither the lawn nor the car porches. So the number of universal set subtracted from the number of lawn union car porch will be equal to what? So I'll write 50 because it is the universal set minus 42 which is their union, and this is equal to 8. So this means that the houses which neither have lawns or car porches are 8. Now we need to represent this data by a Venn diagram. So I'll draw the first set. I'll call this L, which is lawn, and then I'll draw the second set which will overlap because they have common values, and I'll call this C for car porch. Now what will I do next? In the middle, the intersection is 15 and the number of lawns are 25. So 25 subtracted from 15 is equal to 10. So I'll write 10 here. Then number of cars is 32. So 32 subtracted from 15. So I'll have 7 and 17. So I'll just place 17 right here. And then what will I do? I'll just draw this rectangle to indicate the universal set. And then the value of 8 will be placed right outside these two sets to indicate that there are 8 houses which do not have lawns, neither car porches. Attempt question number 3. What does question number 3 say? It says that in a group of 30 mathematics students, 20 like algebra and 15 like both geometry and algebra. So first let's place this data. So the number of union, the union set, what is it equal to? So I'll write here the number of union set, which is mathematics, is equal to 30. Then we have the value of A, which is algebra. The number of students that like algebra are 20, and the number of people who like both algebra and geometry are 15. Now what do we need to find? We need to find the number of people that like geometry only. So how will we find that? We will use the formula of N of A union G is equal to N of A plus N of G subtracted from N of A intersection G. So first thing that I want to clear is that the number of universal set is equal to the number of A union G. So when I use the formula, I directly write 30 because it is equal to N A of A union G. So I will write 30 here. Then it will be equal to 20 because 20 is the number of A plus number of G which we are going to find, and then subtracted from their intersection, which is 15. So 20 minus 15 is equal to 5. So I'll write 30 is equal to 5 plus the number of G. So now 5 will be moved to the left side. So 30 minus 5 is equal to the number of G. So 25 is our answer. Now if we want to represent this data by the Venn diagram, how can we do so? So we will draw the first set, which is A, then the second, which is G. We'll call this algebra, we'll call this geometry, and then in the middle we have 15. Then I'll place 5 for algebra. So this is our Venn diagram. Then next I will create a rectangle to indicate the universal set, and then this is the sign for the universal set. So let's solve question number 5. Question number 5 states that in a survey of 940 children, 400 students were found studying at primary level, 240 students at elementary, and 175 at secondary level. Create a Venn diagram to illustrate this information and how many children were found out of school. So first we need to collect the data. The universal set, which is the number of children, is 940. Then we have the number of children which are in primary school, that is 400. Then the number of children in elementary are 240, and the children which are in secondary are 175. So when we have collected all of this data, there we can see that there is no common element between P and E and S, and P and S. So we need to use the inclusion exclusion principle, which states that N of P union E union S is equal to number of P. So I'll write number of P added with number of E, then again added with number of S. Then we will subtract them. So I'll subtract them with number of P intersection E. Then I'll again subtract them from number of E intersection S, and I'll subtract them from number of P intersection S. And in the end, what we will do is that we will add them with the number of P intersection E intersection S. So by taking a glance at this equation, you will see that we have the number of P, the number of E, the number of S, but the intersection isn't given, so we will consider them as 0. So this means that the number of P union E union S is equal to number of P plus number of E plus number of S, which is 400 plus 240 plus 175. So when I add up all of these, the resultant is 815. So the number of P union E union S is equal to 815. So what if I subtract the universal set from the inclusion exclusion answer? So if I subtract the universal set from P union E union S, what will happen is that 940 will be subtracted from 815 and the resultant will be 125. So now I need to represent this data by the Venn diagram. So I'll draw three sets. This is the first set, this is the second set, and this is the third set. Now these three sets do not have anything in common, that's why they aren't overlapping with each other. I'll call this set primary, this elementary, and this secondary. Now firstly, let's make them a little bit closer. Okay, so now I'll place the values of primary, elementary, and secondary children. So this will be 400, this will be 240, and this will be 175. Now I'll draw the universal set to. So this is the universal set. I'll write the symbol and then I'll write 125 outside of these three sets to indicate that these were the children that weren't in primary, elementary, or secondary school. Okay everyone, so we're going to attempt question number 8. So I'll write question number 8 right here. Question number 8 states that in a girl college, every student plays either badminton or table tennis or both. If 350 students play badminton, 280 play table tennis, and 150 play both, find out how many students are there in the college. So first we will write the data. Number of students that play badminton it's 350. Then the number of students that play table tennis are 280, and the students that play both badminton and table tennis are 150. Okay, so we need to find the union, how many students play all the sports. So which formula will we use? We will use the first formula, which is n of b union t is equal to n of b plus n of t subtracted from n of b intersection t. Since n of b is 350 and n of t is 280, we will subtract these two values and then we will write minus 50 as n bracket b union t is equal to this. Okay, so the answer of n of b union t will be equal to 480. Okay, so this is the answer. But now what if I want to showcase a Venn diagram for this question? So I will create the first set, then I'll create the second set, and I'll call this set B for badminton and T for table tennis. Then I know that the intersection is 150. So if I have 350, it will be subtracted from 150. That leaves me with 200. So I'll write 200 here. And then for table tennis, I had 280. So if we subtract this with 150, so we have 130 left. So I'll write 130 over here. And then I'll just draw the universal set. So this is the universal set, and then I'll showcase this by this. Question number 9. It states that among 50 students, 8 are learning both English and Chinese languages. A total of 26 students are learning English. If every student is learning at least one language, how many students are learning Chinese? So what do we need to find? We need to find the number of students that are learning Chinese. Okay, so what is the data that has been given to us? The number of students that are learning English. How many students are learning English? That is 26. And what is the intersection of English with Chinese? That is 8. Okay, and then what is the union of English with Chinese? That is also given, which is 50. So we just need to find the number of students learning Chinese. In order to do that, we will use the first formula, which is n of E union C is equal to n of E. Then we will write n of C. Then we will write subtracted from n of E intersection C. Okay, so I'll just place the values now. So I'll place here 50 is equal to 26 plus n of C subtracted from 8. Okay, so 26 subtracted from 8 is 18. So 50 is equal to 18 added with n of Chinese. So when 50 is subtracted from 18, we will get our result. So n of Chinese is equal to 32. So this is our answer. And if you want to represent it by the Venn diagram, you can easily do so. How will you do it? You will just draw the first set, then you will draw the second set, and they both must be overlapping. Then you will write some value in the middle. Let's suppose X, and then you will write the value of, let's suppose this is English, this is Chinese. So you will write the value of English subtracted from X, which is the middle value here, and then you will write Chinese subtracted from X here, so let's call it this, and then you will draw this rectangle outside. This is basically to denote the universal set, and then you will draw this symbol. So it's very easy to draw it, but this is optional. So if a question tells you to draw it, then you must do it. And each person likes at least one of the two drinks. How many like tea and coffee? So let's write the universal set. The universal set is 70. Then we have the number of people that like drinking tea. So I'll write here 48. Then the number of people that like coffee are 40. What do we need to find? We need to find the number of tea intersecting coffee. How can we do this? So we will use the formula which we have used a lot of times throughout this exercise. It is the overlapping formula, n of a. So A in this case is T, so I will write N of T union C is equal to N of T plus N of C subtracted from N of T intersection C. Now we will just place our values. So I will write 70 is equal to 48 plus 40 subtracted from N of T intersection C. 48 plus 40 is 88. 70 is equal to 88 subtracted from N of T intersection C. So what will happen now? Okay, so yeah, N of T intersection C will come to the left and 70 will come to the right. Okay, so the sign will be positive. So I'll have N of T intersection C, which is equal to 88 minus 70. The answer will be 18. I'll write N of T intersection C is equal to 18. So this is our answer. The number of students who are either in science or the arts group. So let's write the data. N of science is equal to 46. N of A is equal to 50. Okay, so if I add both of these values, what will I get? I'll get 96. This means that the universal set is equal to 96. And now we need to find the number of S intersection A. Also keep in mind that the universal set that I just found, which is N of U, is also equal to N of A union S. Okay, you just need to remember this. So now I will use the same formula, which is N of A union S is equal to N of A plus N of S subtracted from their intersection. So I just write the values. 96 is equal to 46 being added with 50. Then we have subtracted from N of S intersection A. So 96 will be equal to 96 subtracted from N of S intersection A. Okay, what will happen now? This will go to the left, this will come to the right. So this means N of S intersection A is equal to 96 subtracted from 96. That is equal to 0. So this means that there isn't any common value between set S and set A. Okay, so this will be your final answer. 12, question number 12. It states that in a group of people, 52 people can speak Arabic and 112 can speak French. how many can speak Arabic only, and how many can speak French only if 12 of them can speak both languages. How many people were in the group? Okay, so what will we do? Firstly, we'll write the number of students who can speak Arabic, that is 52. Number of students who can speak French, that is 112. Now their intersection is equal to 12. Okay, now what do I need to do? If their intersection is 12, when I'll be creating the Venn diagram, showing this data by a Venn diagram, I'll subtract these values by 12 because they are used here. So before that, what will I do? I'll now take the union. So I need to find the n of A union F, that is equal to the number of A added with the number of F subtracted from the number of A intersection F. Okay, so let's place the values now. So I'll have n of A union F as it is equal to, what is the number of A? The number of A is 52 plus 112, and then it will be subtracted from 12. Okay, then I'll place here n of A union F, which is equal to 140 and then minus 12. So 140 subtracted from 12 is 128. So n of A union F is equal to 128. Another point to ponder is that many students make this mistake that when they are given the values of suppose A and they are given the values of suppose B, what they do is already subtract their intersection. Look, like for instance, I have the intersection value given. It is some sort of value. So when they are using this formula of overlapping sets, they first subtract it from the common, which is this, and subtract it from here too, and then place those values in the formula. But that is wrong. You're not gonna get marks for that. You're gonna have to apply that for the Venn diagram, not for this formula. Okay, so that was a quick point that I just wanted to clear out for you all. Now we will be creating the Venn diagram for question number 12. So I'll show you. It's very easy. So firstly, I'll create the first set. This is the second set, and in the middle I'll write 12. And then what will I do? I will subtract the value of A with 12 and the value of F with 12. So I have 40, and we had 112 subtracted from 12, that is equal to 100. So I'll have 100 here, and I'll label them. I'll call this Arabic, I'll call this French, and then I'll create a rectangle to showcase what? To showcase the universal set. So this is my final answer. Now let's move on to question number 13, everyone. What does question number 13 say? Question number 13 says that in a high school, 360 students like reading storybooks, 170 like practical activities, and 150 like both. We need to find the number of students who like reading storybooks only, the number of students who like only practical activities, the total number of students in the school. Okay, so let's write down the data first. The number of B is equal to 360 and the number of A is equal to 170. Okay, after writing this, then we have the number of B intersection A, that is equal to 150. So when I will be creating the Venn diagram, I'll subtract these both values from 150, but for now I won't do so. Okay, then the number of B union A is also given, and that is equal to 380. Okay, now what do I need to do next? So this is our final answer. Okay, why? Because in the first part they said the number of students who like reading story books only. So for example, I have the books. I'll show you. These are the books. They are equal to 360. So subtract them from 150. You will get those students who read books only. Then you have A. What does A stand for? A stands for activities. So if 170 is subtracted from 150, you will find the students that just like doing activities only. And then if we want to find the union, the total number of students in the school, what we will do, we will add these values. So the resultant values, when we add them, that will be equal to the universal set, or the union of A and the union of B. So this will be your answer. Okay, now if I want to showcase this by a Venn diagram, you can do so. Just follow the same steps. I'll just not get into that right now. Let's attempt the last question of this exercise. So question number 14. What does it state? It states that in a survey of 60 people, this means that the universal set is 60. It was found that 25 people watch channel A, number of A is equal to 25. 16 watch channel B, 13 watch channel C, 14 watch both A and B, 7 watch both B and C, 8 watch both A and C, and 3 watch all three channels. Okay, so after reading this question, I didn't read the full question, but I noticed that we have three sets. So when you have three sets anywhere, automatically you should know that maybe there will be an inclusion exclusion principle being applied to it. Okay, so find the number of people who watch at least one of the channels, and we need to find the number of people who do not watch any of these channels. So how can we solve this? Let's first write the universal set. The universal set is equal to 60. The number of people who watch channel A, it is equal to 25. The number of people watching channel B is 16. Number of B is equal to 16. After that, I will write the number of people watching channel C, that is 13. Okay, then we have the number of people that watch both channel A and B, so that is equal to 4. The number of people that watch B and C, that is equal to 7. And then the number of people who watch A and C, that is equal to 8. And then we have the people that watch all three channels. This basically means A intersection B intersection C, that is equal to 3. So automatically we know that we're gonna use the inclusion exclusion principle to find what? To find N of A union B union C. So we're gonna find this. So how can we do that? Let's just fast forward this. So it is very easy to solve. What we will do, we will add the number of A with the number of B with the number of C. Okay, then we will subtract it with the number of A intersection B, which is 4, then with B intersection C, then with A intersection C, and then we will add it in the end with 3, which is A intersection B intersection C. So we will just write here that number of A union B union C is equal to 38.